Michale, jsi si jistý, že to je... Už slyšíš mikrofon? Jo. Okay, I guess it's time. So, let me briefly start the meeting. Thanks everyone for coming here. I'm very happy that we made it. This event has been planned for quite a long time. We're all quite a long time thinking how to make it, how to organize it. So I'm quite happy we finally made it. So thanks very much for coming for this event, which is organized by Czech technological platform for additive manufacturing, and partly by a cluster of mechatronics, and will be supported by the Ystm guys who joined us here today, which I'm really proud of. So the reason why we gathered this meeting, actually, it was just most of us are somehow dealing or are planning to be dealing with the additive manufacturing, and as we are not the only country which is dealing with that, so it would be quite good to learn a little bit from the outside and also to make some plans how to where we wanna get and how we wanna get to that target, and that's something what we would like to make based on today's meeting and our previous activities together with the people from the Astm. So the target is to prepare a roadmap for additive manufacturing in the Czech Republic. This roadmap will be based, of course, on your ideas, your needs, your wishes, and also on the experiences from the outside. Why that's main reason why we have people from the American Society and Testing Materials, especially from Center of Excellence for Additive Manufacturing here, which are represented by Martin and Alberto here. So these are two most important guys today, probably. Next to you, of course, they are the ones who are going to pick up those strawberries, what you are going to talk about, and put it on the cake in proper direction, proper orientation, and proper order. So that's why they are here, and all of us together. So the program is presented here right now. It's just a brief introduction, and then we will just straight go for some work, hard work, and that's what Martin is going to tell us about what they would like to, what kind of inputs, how would like to get it. So that's probably the end of my warm welcome here. I think most of you have recognized already that the coffee and some refreshments are over there. I guess there is something still outside. So if you are feeling hungry or thirsty, just help yourself. That's all that is here for you to make you feel comfortable and to support you to provide the best performance today in order to support our activities. So with these words, I think I'm more or less done, and I would hand over the word to Martin, who will tell you more details. So thanks very much once more, and I'm looking for a fruitful, efficient meeting today. Okay, thanks.
Good morning, everybody. I'm just going to battle the IT demons. Excellent. Okay, so good morning. Welcome, everybody. My name is Martin White. I'm from the ASTM International, particularly with the Additive Manufacturing Center of Excellence. I wanted to kind of just set a little bit of the scene today, as Jan kind of gave the introduction. The objective today is for me to speak as little as possible. We're here to try and engage with you guys, to build a successful roadmap and understand the challenges and the requirements. It needs some input. So hopefully today will be fun. So there's plenty of strong coffee, so that's good. The ambition is to allow you guys to ask questions, get some experience. So my colleague Alberto is here as well. Alberto has a lot of process experience. He's worked in automotive, medical with additive before. My background is primarily around safety critical applications. So I've mainly worked in aerospace and nuclear. I was a former chief engineer at GKN Aerospace in the UK for their additive manufacturing facility. So I've had the sort of the fun part of signing off documentation for certified parts that are now flying. So why ASTM? Why Ystm International? So the ASTM is obviously a standards body. So we develop standardized processes and documentation to support application industry. And in terms of our additive manufacturing footprint, we have two main approaches. So one is through our standards committee, which is F42. We're very proud to have a partnership with ISO through TC 261. We now have, I think, almost 50 standards available. So the conversation is no longer, why don't we have standards? It's now, there are a lot of standards, where do we start? So I'm happy to have some discussion around that today. I think we now have, I think it's over 1,200 members, significant membership outside the US. Jan, if you look on some of the photos of previous F42 meetings, you'll always see Jan at the back smiling, trying to hide away, but he's quite tall, so you can still see him in the back. And crucially, this kind of structure has allowed us to kind of accelerate. So with the rapid acceleration adoption of additive manufacturing, ASTM decided that standards, they're a little bit slow to create. So we created a Centre of Excellence, which is actually a technical team. So we now have over 20 team members globally. So myself and Alberto are based here in Europe, based in the UK, but Alberto is from Italy. And the aim is to try and accelerate standards. So one is share the standards that exist, understand where the gaps are, and help to develop. And secondly, to try and support some of the education and training. So a lot of the questions we get asked are quite consistent of where do we start with additive, how do we bring parts to market, how do we build facilities that are capable of producing quality components. And the most important thing about the ASTM is everything is done in collaboration. So we are an independent body, we are not for profit, we are here to support industry and obviously through the creation of standards. And we're very proud of our partnerships with our core partners there you can see on the screen. So in Europe we have the MTC, who are based in the UK. They're a manufacturing catapult centre to accelerate manufacturing. Auburn University in the States, NASA, EWI, NIAR, and also NAMIC in Singapore. So we are a global organisation. The aim is to try and help industry to go faster. Events like today, because we're now a growing technical team, we're able to support on these things and hopefully share our experience, and not just the experience of myself and Alberto today, but also to dock into some of the wider ASTM experiences as well. So just to set the scene of today, so I always kind of go back into engineering mode. I always like to start with requirements. So what do we want to achieve? How do we want to do it? And when do we want to do it? So there's a couple of key fundamental questions I wanted to start the day with. So why do we need a roadmap? And what are the expectations for today? And you've probably, it's great to have people here in person. It's fantastic to have finally left the UK to actually have some face-to-face technical discussions. But I wanted to kind of ask those questions today. And in terms of what do we want to do and why? So when working with Jan and the team of building a roadmap for the region, I always kind of start with, well, what do you want from the roadmap? What are the key questions? What are the objectives? What are the timescales? And try and start with that today. So some of the exercises today, it isn't going to be death by PowerPoint. This is going to be very, very short. There's some whiteboards. We'll be having those open discussions. I also like to think about accountability. So creating a roadmap is a fantastic thing to do. It gives direction and real understanding, and it's a good line in the sand. But something I'd like to try and explore today is how do we understand whether we've been successful? So what does good look like? I guess to use the industry phase. So how do we determine the timescales? How do we have some governance around this roadmap? Possible formations of things like advisory boards, etc. And then finally, implementation. So what I've also found is very much don't like to reinvent the wheel. So quite often you find there's similar technologies where roadmaps have been created. You may have experiences in powder metallurgy or sort of systems that are alongside. And how do we then try and implement? So last couple of slides. So end of last year we held a virtual workshop. And the virtual workshop was sharing of kind of the state of the art in additive, some of the standards landscape, some of the products and components are out there today, and I managed to take quite a lot of notes and discussion, and even though it was virtual, I think I was on the screen, and I think some of you were here. I tried to pull out some of the key points, and when we kind of go through the discussions today, I think some of these questions will come up again. So, for example, already this morning I had a discussion with Martin at Saffron around where do we start to put components into aircraft into service? How do we do it? And you can see that there's a range of topics there that to be covered. So I think one of the fundamental is we can set targets, but unless you consider how you build like a trained workforce and where are your skills, development gaps and needs, that's pretty key as well. And again, you can see the range of some of the industrial questions around things like how do you create additive manufacturing data sets, and then there's the more perhaps the longer term academic interests around understanding more about 4D printing and things like that, and what is it. So these are some of the topics I kind of pulled out top level. When we think about the requirements, again, from personal experience in bringing new technologies to market, there's kind of multiple approaches. With additive manufacturing, I always like to think of who actually wants additive manufacturing. So rather than developing a technology and then saying we've got this amazing technology, who wants it, how can we engage with potential end users to get that pull for the technology? And just in terms of, and I think we can share these slides, in terms of thinking of that pull from industry in particular, what is the world going to look like over the next 3, 5, 10 years? So I built this map 2 years ago, pre-COVID, so it's already changed probably quite significantly with things like the hydrogen technology and low carbon technologies. But when we build this roadmap, I think we'll be considering short, medium and longer term, and that has to reflect what the industrial platforms will look like. So my biggest experience is probably with aerospace, so what are the future platforms for aerospace, what aircraft, helicopters, etc. are going to be coming out. Defence is another interesting one. So in the UK, we've launched the Tempest project with BAE, and they have specifically said that platform will have over a third of the manufacturing route will be additively manufactured, which is quite a significant jump compared to today. So it's worth thinking about these future platforms in energy, defence, aerospace, automotive, because then that helps build an aim for the region. Do you want to be a part producer? Do you want to be a service provider? Do you want to be a hub for training, etc.? And this kind of thing will help you move forward and think about those things. So I believe we're going to have a session where we can sort of pitch from each company next, and then we're going to have a couple of exercises. So this is where you get to no longer listen to me, and we're going to kind of have a bit of an engaging session. We're going to split the group into two, and there's 4 kind of key blocks we've identified. So around the technology of additive, the application and use of additive. My colleague Alberto will be leading this discussion on that side. So Alberto is an applications and process specialist. And then the other discussion will be around things like infrastructure and also people. So the infrastructure side is, do we buy AM parts through the supply chain, or should we look to make them and have our own facility, and how do we build our own facility? And the people side is, what skills do we need to enable these methods as well? So that will be the first working group. We also have a digital whiteboard that we can share with everybody online, so that everybody online will also be able to participate. And then the final activity will be looking at identifying strengths, weaknesses, opportunities and threats. This is a common tool used in roadmaps. So this is an example from the UK additive manufacturing roadmap. And this is probably a good one to do near the end of the day, where we can be reflective. It helps sometimes to be sort of critical of genuinely where are the things that need to be improved. And this then helps you identify what the priorities are, and then from that you can develop your roadmap. So those are the exercises for today, and they are designed to hopefully be informal. And once we all kind of get to know each other a bit, and you can ask some questions, later on we'll get back together and have the reflection on the discussion. And for me, what I like to try and do is take the output from your thoughts, and then that starts to feed into this roadmap and the priorities, because we're probably going to come up with a list of about 100 things. So what are the most 5 important things that you guys wanted to focus on? So that's the kind of the aim for today. And I will hand over now to do the pitch sessions. And please feel free to grab me during coffee break and have a discussion. And yeah, I look forward to speaking with you all today. Thank you.
Good morning. My name is Michal Sieber. I'm R&D engineer in company Prospon. We are a Czech producer of medical devices, especially surgical implants for orthopedics, trauma oncology. The company is located in Kladno, which is 20 kilometers far from Prague, the Czech capital. We have an AM machine since 2016, and we are using it especially for making individual patient-specific implants. We are using a powder bed fusion machine, a laser-based one. It has some advantages and disadvantages, but this one suits us the best. There are some good things about additive manufacturing, which is highly beneficial for medical devices. It's a biocompatibility and mechanical properties, and safety in some manner compared to, let's say, a classical way of preparation of osteogenetic coatings, and of course design complexity. This is maybe the greatest advantage. We use additives for making a patient-specific implants. We receive patient data in form of CT scan, and through the segmentation process, we create a 3D model, and according to that, we can make a patient-specific implant. This is just a few pictures how it goes. Together with the implant, we are often building patient-specific instruments, which are sometimes made from metal, sometimes from plastic. So we use another additive manufacturing methods. And these are some examples of our recent cases. Most of them are tumor-related prostheses, when the big amount of bone has to be replaced. And on the right side is a case of severe hip dysplasia. At this moment, we have one CE-marked product for serial standard production, but most of our production aims to custom-made for individual implants for those oncology patients. Something for post-processing. This is maybe the most difficult part of the production. And maintaining quality management is a big goal, something we are really, well, this is maybe the hardest. I will definitely talk about this. Okay, thank you. This is for my short, brief introduction.
Morning. My name is Martin Stefaniat, and I am from Safran, Dublin. And I'm here because we are focusing on the additive manufacturing implementation as a production process in the future to produce the standard parts which will be used in aircraft. That's all from my side. Thank you.
Morning. My name is Lukáš Pelikán and I am from Czech Technical University in Prague, Faculty of Mechanical Engineering. Well, we all believe that 3D printing and especially metal 3D printing is amazing technology, and we believe that 3D printing is going to be a future. But we all know that you need much more than just a 3D printer itself. You need like hundreds of things around to be succeed. And well, we have it. We have all the softwares for topology optimization, lattice optimization, and so on. Softwares for simulation of process. Of course, the 3D printer itself, Concept Laser M2, which is a middle-class machine for powder bed fusion, heat treatment, and we have also all the hardware for post-processing, including CNC machines, multi-axis grinders, and turning machines and everything. And also very important is the NDT, and that is our flagship computed tomography, which is very helpful tool for the additive manufacturing. And thanks to this equipment, we are able to produce parts from aluminium, stainless steel, tool steel, Inconel. We making small parts, the big one, and also parts for aerospace, and also some parts are actually in the planes and they didn't fall yet. So I believe that we do it goodly. So maybe last word, we are open to cooperate on some development projects, on some production projects, or we are able also to be your supplier of additive manufacturing parts. Thank you.
So hello everybody, my name is Matěj Rot, this is my colleague Martin Bureš, and we are from the West Bohemian University, specifically from the Regional Technological Institute, where we have the 3D printers, where we deal with additive manufacturing. And just to shortly introduce who we are and what we do, we've been working on additive manufacturing for about 7 years now. Recently, we've also bought a second printer equipped with monitoring systems, which are pretty beneficial for us right now. We are focusing quite a lot of research on it. But so far, we've been dealing a lot with investigation of materials, with finding out how to reliably test the materials, how to evaluate them properly, since the materials are, of course, a little bit different in terms of structure, in terms of their properties than conventionally wrought materials. So this is one of our main focus, but besides that, we've been also focusing on connection with the industrial praxis, which means that we've been investigating the machinability of the printed products, surface treatment, which maybe my colleague can tell a little bit more about.
Yes, so we have not only 3D printing, but also some other processes which we can apply on surface treatment on 3D printed parts, like it's drug finishing, grinding, machining. But we are trying to also apply some unconventional surface treatments, like it's laser polishing, which we do with cooperation in Aalen, in Germany. And also we did some interesting project regarding surface treatment of additive part, actually with Auburn University. I've actually stayed for 3 months in Auburn University and then came for internship, and we are working on laser polishing and stuff like that. Yeah, so also we are researching it, surface treatment, improving fatigue life, etc. And together with monitoring systems, like defect formations and etc. Yeah. Also, my colleague also can tell us about some project. We was in Portugal right now, so.
Yeah, also concerning the surface treatment, we've been focusing on that quite a lot. So we've been working on the project Stream, which deals with surface treatment of additive manufacturing parts by different means. And so our research and our cooperation has been not just on the local scale, but also in America and Portugal these days. And maybe one of our other main focuses right now are the monitoring systems that we've been working on, where we are trying to find out how to reliably find or identify defects in the parts, which is kind of problematic. So in the future, we are also aiming to purchase the CT machine so that we can kind of correlate the results that we get from the monitoring systems, from the thermal camera monitoring, with the X-ray results. So that's one of our plans in the future now. And yeah, I think that's it for our short introduction. Sorry for the lack of visual aids. Okay, thank you.
Thank you.
Okay. So hello everyone. Hello from my side. My name is Andronov Vladislav, and I'm representing here Škoda Auto company. I'm here. I could say that right now, since February, I'm responsible for 3D printing activities in Central Technical Service Department in our company. So that's it. And exactly, I need to point out that right now we don't have our own printer, but it's quite like bad news. But it's right that also we are part of Volkswagen Group also, so there are printers and we can cooperate with them. We also cooperate with universities and so on and so on. But I can say and I can show you that. We use this technology for, I don't know, 7, maybe 8 years. And what do we print and why? So exactly, we are kind of provider in our company for other departments. And what we print exactly, first of all, is our main core business, yeah. And because I was PhD student and I was member of PhD program in Škoda Auto, so I'm write my dissertation thesis in casting tool production department. So first of all is tooling for high pressure die casting, and why we print these tools. Of course, conformal cooling, one of the biggest benefit. Which can improve casting quality, reduce the number of repairs, increase the lifetime of our tools, and so on. And other categories is mainly we are using them for other departments like jigs and fixtures, for our R&D department, also prototyping. When the biggest benefit is, of course, that you don't need like prototyping tools. You can reduce the production time, and also there is the biggest flexibility for any change which you can make on your part. And exactly one of the largest projects what we did in past is this one, and for us it's a really big experience, and it's really good that I can show you these slides, because exactly this is the project when we cooperate with Audi in Ingolstadt. It's like a proof of concept project for us, because exactly what we did, you can see here, we print the wall slider. So really a big part, dimensions of this part you can see there. And yeah, we made it. We made it with cooperation with Audi Ingolstadt in M400 AOS machine. And of course, there is a lot of faults, that there is a lot of residual stresses and another disappointments for us. But I can summary that for us it's also a lot of experience, and this project showed that still in additive manufacturing there is also a lot of undiscovered topics. Yeah, and when we if you want to know something else, you need to try and discover it. So maybe for some of you it could be beneficial that you see that it's that it's really we can print a lot of parts like this, and maybe it's the future, maybe not. So thank you for your attention.
Thank you very much. So regarding the AM, we've been dealing with that also a couple of years by now. So as it was already mentioned, the AM is not just the AM machine itself, but you need also some other infrastructure to support those things, because otherwise it doesn't make a sense. So we cover a little bit wider range also next to the AM deposition, just so we have possibilities for design topological optimization, material models for AM parts. We do simulation of AM processes in order to find tender spots and potential problems with the residual stresses and potential fractures of such things. Then we do also AM deposition. Right now we have two DED systems which are able to deposit multiple materials at the same time, so we can create functionally graded materials, multi-material components. We have a small powder bed system which is going to be soon subsidized by some bigger one till the end of this year. And then we have extensive possibilities for analyzing, ranging from metallography, fractography, over testing of samples, components, up to local characterization, and also execution of some complex tests of whole parts under various loading conditions, including temperature testing and also dynamic testing. So, as I said, mainly nowadays we are dealing with DED. With that one, we are able to deposit quite a wide range of materials. Here we are not only depositing just components, but actually recently we are more doing like repairs or adding just a small piece of material on already build up or existing components such as dies or some cutting tools and so on. So because in many cases AM it's slow process and it costs a lot of money, so sometimes it's easier just to use its advantages only on a special case, special parts of the components that we are talking about. So here is just an example that we can deposit it on some complex shape planes also. As I said, we are dealing with multiple materials, so we can make it like a functionally graded materials, connect multiple materials together. We can also like deposit mixture of materials simultaneously. Here is some list of materials that we've been dealing with, but we did also some some components with the composites. So we put some fine particles into the build to see what happens, how far can we get, and these are just the examples. So we can build up something, we can repair, and we can deposit like multiple material components. So that's probably right now. And the fields of application, actually, we are dealing quite a lot of with biomaterials. We are collaborating quite a lot with Prospon and with Medin, which are bioimplants companies in the Czech Republic. But we do also for industrial partners, like for forging companies, heat treatment companies, and so on. So that's right now what we are doing. And actually, the perspective where we want to go is to deposit like some more funny materials, like high entropy alloys with variable composition, local composition over the component, to make like composites. I am deposited composites and made parts of that, and made parts with local special properties. So that's what we are right now working on, and we would like to be working further on. That's all. Thanks.
Okay, so that was our pitch session. Now we know each other, what we are doing. So now, okay, could I? I'm sorry. I started to close it up. Okay.
Will be without the presentation, just a logo, but
It's yours.
yeah, thank you so much. Let me introduce. My name is Antonín Rudolf, and I am from Škoda JS. It means we are producer for nuclear industry. I think that we are using additive manufacturing almost 12 years. We don't have a problem with the jigs and fixtures and parts of our product, but I think now is the biggest challenge is qualified the important parts for nuclear safety. And another biggest challenge is that we are missing the standards or code in Czech Republic for qualification of these parts. And this is the reason why I'm here, and I would like to discuss about it and get important information. Of course, I know the Ystm code, and I know that there is the part focused on the nuclear industry. Thank you.
Okay, so now this is it. Over. Okay, so it was a pitch session. So we have here representatives of different industries: aerospace, energy, biomed, automotive, and academia, research universities. So we selected these representatives of different parts who are dealing with additive manufacturing to have chance to discuss these opportunities and visions where additive manufacturing is going and how we can use it in Czech Republic to support our strengths. Organization-wise, now we will have a coffee break, networking session, and then we will have first exercise to compile our visions about technology, people, infrastructure, and applications. Exactly. Okay. So please help yourself with coffee, refreshments, and we will start in 15 minutes, or it's at half. Yes. So it's 10:15, so 10:30 we will start next session. Okay, thank you.
Okay, everybody. Please feel free to keep eating and drinking. My Italian colleague must be fueled with coffee regularly, so